Suppose that 13 cards numbered 1 through 13 are arranged in a row. The task is to pick them up in numerically increasing order, working repeatedly from left to right. In the example below, cards 1, 2, 3 are picked up on the first pass, 4 and 5 on the second pass, 6 on the third pass, 7 through 10 on the fourth pass, and finally 11 through 13 on the fifth pass. Let's check that this is true. So from left to right, the first time we see 1 is here. Now we see 2 and 3 to the right. And then on the second pass, so let's say this is pass number 1. The second pass, we see 4 here and then 5. That's it. On the third pass, again, we see 6 here. That's it. We don't see 7 to the right. And then on the fourth pass, we see 7. Then we see 8 here, 9 here, 10 here. And on the fifth and last pass, we see 11, 12, and 13. We are done in 5 passes. For how many of the 13 factorial possible orderings of the cards will the 13 cards be picked up in exactly 2 passes? So we want to pick them up in exactly 2 passes. All right. Now let's see, what does it mean to have to do this in exactly 2 passes? In the first pass, because these are all 13 numbers, in the first pass, we may see, let's say 1, we'll see 1 at some point, right? Now we may see 2 at some point, 3 at some point, and then let's say K is the last one we see on the first pass. On the second pass, we have to see all the numbers K plus 1 through 13, right, in that order. So this is the first pass, and then this is the second pass. So basically, we don't know what K is, but once we know what K is, then the order of the first K numbers are fixed, right, from left to right in increasing order, and the order of the last number, K plus 1 through 13, all those numbers, remaining numbers, is also fixed, right, from left to right. They should be in increasing order. Okay, what do we know about, the spaces in between, right? Where could these K numbers be? Well, K plus 1 cannot be to the right of K because otherwise we would have gone through K plus 1 in the first pass, during the first pass, right? So that means K plus 1 should come before K, right? K plus 1 should be before K. Okay, well, it's going to be before K because K plus 1 is the smallest number in the remaining number, in all the remaining numbers. So it's going to be before K as long as there is some space, right, here. So the only bad case is when there's no space among 1 through K, right? They're all consecutive and they take up all the first K spots. Then K plus 1 would have to be to the right of K, which is bad because we cannot go through it in the second pass. Okay, so that's the only bad case. And the possible values for K are 1 to up to 12, because if K were 13, there would be nothing left. It would be done in 1 pass, not 2 passes. All right, so what are the possibilities for each of these K? How many orderings do we have for each of these? Well, given K, we can order the first K numbers. We have to choose their spots, right? So this is to choose the places for 1 through K. And after that, the remaining spots are going to be fixed, right? So only one case for the places for K plus 1 up to 13. But this would be a bad case, right? If among these 13 choose K possibilities, one of them is bad. Because if they occupy all first K spots, then there's no possible place for K plus 1 to be to the left of K. So these are all the possibilities, all the good possibilities for the first K numbers. All right, let's continue. And then K can be 1 up to 12. So we need to write this and Right? So when k is 1, we have this many possibilities. When k is 2, we have this many possibilities, etc. When k is 12, we have this many possibilities. So if we sum let's combine the combination terms together, and then the minus ones, we have 12 of them, right? So these combinations, if we had 13 choose 0 and 13 choose 13, so we know this from basic counting, this whole sum is 2 to the 13. You can see this either by binomial, right? 1 plus x to the 13, or 1 plus rather 1 to the 13, right? Is 13 choose 0 plus 13 choose 1, etc. I think that's the easiest way to see this. So all the combinations add up to 2 to the 13, but this one is missing the first and the last one, and they are both 1. 13 choose 0 and 13 choose 13 are both 1, so we are missing those two. And then minus 12. So the answer we are looking for should be 2 to the 13 minus 14, and it's good to know 2 to the 10 is 1024, so 2 to the 13 would be 8 times that. So 2918, so 8192. And I mean to subtract 14 from there, so we get 8178 is our answer. See, that's answer choice D.